Okay. Hi students, welcome to this session on signals and systems. Okay, so let's get started. So we will be discussing some amazing, excellent questions based on signals and systems. We'll be looking at some very fundamental concepts and how to apply that concepts and how tricky these concepts can get in gate. All these things we will look into it quickly. Okay, so without wasting much time, let's get started. So first of all, welcome to this quiz. Let me quickly walk you through the instructions for the quiz. So you are going to get 5 questions. So all of them are going to be multiple choice questions, are going to be of directly numerical based questions. Either of these case, either it will be of either of this kind. And let's look at the instructions. So the questions, kindly the link is given here. So go to this link bit.ly/tga/077e link, and you will be getting the questions there. Each question will come up, and after each question you get around 2 minutes to answer for this question, and after each question we will see who has answered, and then finally we will have the winner. And after all the five questions are completed, we will be discussing the question solutions also for the questions. And there are no negative points, and the number of points per question will be displayed along with the question. The tougher question will have more points, and faster you answer, you are going to get more points. If you are able to get the correct answer quickly, you will be rewarded with more points. So that's where the fun is real. Okay. So wish you all the best. Let's get started. Let's see how many players are joining. Welcome, Mahesh. We'll wait for a couple of more minutes for others to join. We will wait for 2 more minutes. So if you see from from the gate point of view, the basics of signals and systems are very important really, because mainly for EC, EEE and IN students, this signals and systems forms a very important topic in GATE. And also it's like it's a very important subject we need to have a clarity on for our higher studies also. That's why it's important for GATE. And if you see the principles that are getting covered in signals and systems is what you will be tomorrow when you start your career in, let's say, in any electronics design or anything, you will be applying all these principles you're studying in signals and systems and control systems during that electronics design, so that you are obeying the fundamental principles of signal processing in the circuit. At the end of the day, the circuit is going to process some signals, so we need to know how to process the signals, what are the properties of the signals, and how the signal is actually getting processed by the system. So what all to expect, what all we should not expect based on that. So practically that's the significance. From gate point of view also, this topic has roughly around 10 marks weightage in gate roughly. So this is really very important from gate point of view also. So which makes this subject very attractive actually. Okay. Okay. Just a second. Just give me a second. Okay, let's start the quiz. Let's see, I think we may be having some. Okay, let's get started. All the best, Mahesh. Let's get started. So here comes the first question. So the system is described by the difference equation. So basically, we have a system shown in the signal, basically in the block diagram. So what is the difference equation that is describing the system is what is the question being asked. So the options are given, four options are given. What is the correct difference equation which describes the system is what is being asked. So we have approximately last 30 seconds remaining. So these type of questions are very famous and very common in gate type of examination. So all the questions we are seeing here are going to be also picked from either gate or similar competitive examinations or some very good problems from some collection of problems based on that. So almost last 10 seconds remaining. Let's see. Let's see. Okay. So y of n minus 2 y of n minus 1 equal to x of n plus 3 x of n minus 1. This is the correct answer. I think people have picked the wrong answer. No problem. We can see what happens we can catch up in the next question. Let's see. Hey, good afternoon. Let's get started. So here comes the second question. I think, okay. Abdul, you have joined. I think you can also start taking the quiz. That will be nice. So here comes the second question. So the Laplace transform of e power at u of t converges to 1 by s minus a everywhere in S plane, or it is conditionally converging for real part of s greater than a, real part of s less than a, real part of s less than minus a. So this is a very beautiful question. So we sort of take these are like Laplace transform identities, and we sort of take it for granted, but there are some intricacies to this. So, so, so this question is actually going to talk very, very interesting point about the Laplace transforms actually, what exactly it is trying to do. Cool. Everyone has given the correct answer. That's awesome. That's awesome. So there are four people and all four have given the correct answer. That's very good. Wow. This is where the real competition is. Now it is picking up. Let's see. That's good. That's good. Let's see. Here comes the third question. Okay. What is the Laplace inverse of log of s minus a by s plus a? What is Laplace inverse of log of s minus a by s plus a? So we know how to compute Laplace inverse of a normal function, but it's a log is being asked here. So something we have to look at it interestingly. So wow, everyone has given the answer. Good. Three people have given the correct answer. That's amazing. That's amazing. So so good. I think the competition is really picking up here. Let's see. It's a close fight between Mahesh and Mishra. That's good. Let's see. Let's go to the fourth question. The impulse response of a system is given by h of n is 1 by 2 power n u of n. If x of n is 2 delta of n plus delta of n minus 3, then what is y of 4? So this is a numeric type of question. Let's see. Okay, last 45 seconds remaining. Let's see. Let's see. So we will discuss all the answers for this problem also towards the end. Let's see. 8 plus 8.625. Hey, 0.625 is fine. So 0.62, 0.625 both are correct answers. So don't worry about this. I think 0.625 is also. I will accept 0.625. I will accept this answer. So we have, okay, let's go to the next. Wow, this is getting interesting. Let's see. This is the last question coming up. So you have been given the differential equation of the system. So what is the step response of the system is what is being asked. So again, these type of questions are very, very common in competitive examination questions. And I like to grab your attention here. The options given are not randomly given. They know the mistakes the students will make based on that the options are given. So almost last 45 seconds. Let's see. Last 10 seconds. It's going to be interesting competition. Let's see who is our grand winner. Wow, time's up. Okay, so only one of you have given the correct answer. That's good. Let's see. Wow, Mahesh is clearly the winner with 326 points. That's awesome. Congrats, Mahesh. That's really awesome. That's really awesome. So the main purpose of solving all these problems are like to get accustomed to all the like the interesting concepts that's being covered in gate, and we will look into the detailed solutions of all these problems. Okay, so you see the basically ba- time and again I always been saying the same thing. Gate problem need not be very complicated, very tough, and it's a laborious problem. No, it's not like that. All the problems will be very tricky. A concept will be just like that given to you. It looks like to you like a very, very straightforward thing, but there will be a small trick or small caveat there. That's what it is. So let's look at those type of caveats what all are present in these problems, or the interesting things what they are trying to corner us. Okay, so I'm stopping my sharing for a second. Let me bring the notepad for solving and then share it again. Okay, so this was the first question. Okay, okay, so we'll discuss the solutions for this question, and then we will look at the all the, I'll be very happy to answer all the questions you guys have also. That let's start discussing the solutions. So this was the first question. So we were asked to find one second. So we were asked to find the difference equation describing the system, difference equation of system. This was what was asked. Correct. So I am assuming this intermediate point as some lambda of n. So this is z inverse. So z inverse is nothing but delay in time domain. So this becomes lambda of n minus 1. So this becomes 2 lambda of n minus 1, and this becomes 3 lambda of n minus 1. So now I'm going to write the equation for y of n. So y of n is lambda of n plus 3 lambda of n minus 1, and my x lambda of n is x of n plus 2 lambda of n minus 1, x of n plus 2 lambda of n minus 1. So I'm going to take z transform on both sides. So lambda of z will be x of z plus 2z inverse lambda of z, because z transform of lambda of n minus 1 will be z inverse lambda of z. So grouping now lambda of z into 1 minus 2z inverse equal to x of z, or lambda of z by x of z equal to 1 by 1 minus 2z inverse. Now if I take z transform here on both sides, what will I get? Y of z is equal to lambda of z plus 3z inverse lambda of z, which implies y of z by lambda of z equal to 1 plus 3z inverse. So therefore y of z by x of z, which is the transfer function of the system, is y of z by lambda of z into lambda of z by x of z, which is nothing but 1 plus 3z inverse divided by 1 minus 2z inverse. So which implies y of z into 1 plus 2z inverse is equal to 1 plus 3z inverse into x of z. So if I now, sorry, 1 minus 2z inverse. So, so now if I take the inverse z transform by inverse z transform, what will I get? Y of z inverse z transform will give me y of n minus 2 y of z z inverse. So that will become 2 y of n minus 1 is equal to x of n plus 3 z inverse x of z will become 3 x of n minus 1. So this is the solution. So let's go to the second question. Laplace transform of e power a t u of t is 1 by s minus a. What is the ROC? That's what they're asking. What is the ROC? Correct. Let us look at the Laplace transform here. So what is Laplace transform of x of t? It is nothing but integral minus infinity to infinity x of t e power minus st dt. Correct? Correct. So let's see what happens here. So implies Laplace transform of e power at u of t will give me integral minus infinity to infinity e power at u of t e power minus st dt, but u of t exists only from 0, so this becomes 0 to infinity e power at into e power minus st dt, which is nothing but integral 0 to infinity e power minus of s minus at dt. So now if I take the integration, I will get e power minus s minus a divided by s minus a. Of course, there's a minus symbol here between 0 and infinity, which is nothing but t. So which is nothing but limit t tends to infinity. I have to evaluate this function at infinity, correct? E power minus s minus a t divided by s minus a. The limit is only for this. Minus of minus will become plus 1 by, because when I substitute 0, this will become 0. E power 0 is 1 divided by s minus a. So this will converge to 1 by s minus a only when this factor is becoming 0. So now the question is when this factor will become 0. Implies limit t tends to infinity, e power minus of s minus a t divided by s minus a is equal to 0, which means the numerator becomes 0 because the denominator cannot become see the numerator, it is taking the value as t tends to infinity. So t is the variable. So denominator, see, a fraction is becoming 0 means the numerator becomes 0 or denominator becomes infinity, but the denominator is independent of t. So denominator is not becoming infinity, it's the numerator becoming 0, which means limit t tends to infinity, e power minus of s minus a times t equal to 0, which means s minus a is a positive number, because only when s minus a is a positive number, I will have overall number, overall term as e power minus t, and e power minus at will be e power, let's say for example, limit t tends to infinity, e power minus constant into t will be 0 for c greater than 0, correct? Correct? There's a constant. So this is what we are trying to say, which means s minus a is greater than 0, or this s is a complex number, sigma plus j omega minus a is greater than 0. This j omega term we are not bothered, because j omega, e power j omega t is sine and cos, which is never going to die down. So we are looking for mainly sigma minus a greater than 0, or sigma greater than a, which is nothing but real part of s greater than a. So this is the solution. So Laplace transform and Z transform will have a region of convergence, and it will converge to the answer only when that region of convergence is met. The criteria given by the region of convergence is met. Only Fourier transform will be converging everywhere in the omega plane. Clear? The Laplace transform and Z transform may not converge at every point. We need to be very careful when we are taking Laplace transform and Z transform. Whenever we are quoting Laplace and Z transform, kindly note we should always quote it along with ROC. This is very important. Okay. Okay. Let us go to the third question. So the third question was Laplace inverse of log of s minus a by s plus a, correct? Or what was the question? Let me see. S minus a or s minus 1? Let me see quickly. Just a second. It is s minus a by s plus a. Okay. So it is s minus a by s plus a. So this is the question, log of s minus a by s plus a. So now I don't know any function whose Laplace transform gives me log. For me to apply log inverse of, see, for example, whenever we take Laplace transform of e power at u of t is 1 by s minus a. Laplace transform of e power minus at u of t is 1 by s plus a. Something like that. We know this pair. So whenever we see this, we reverse map it this way. Correct. But here, I don't know any function whose Laplace transform will give me log such that for me to do a reverse mapping when I'm taking Laplace inverse. So I need to clearly use some properties of Laplace transform. Clearly, we need to use properties. Clearly, we need to look for properties. Suppose if I have 1 by s minus a and 1 by s plus a, I know how to calculate this. Now, how can I get 1 by s minus a, 1 by s plus a from this? Let's see. So now, L inverse of log of a by b can be written as log a minus log b. So I can write this as log of s minus a minus log of s plus a. So from log, how can I get this? If I differentiate log, I will get this. Correct? So let me call this as f of s. So this is my f of s. Now what is the property I am going to look for? Laplace inverse of f dash of s, or Laplace inverse of minus f dash of s is t into f of t. This is the property I'm going to look for. This is a very important property which comes to us in handy. So let's see. So now log of s minus a. So what is f dash of s? F dash of s will be 1 by s minus a minus 1 by s plus a. So minus f dash of s will be, this is minus, this is plus. So which is 1 by s plus a minus 1 by s minus a. Now I can very easily compute the Laplace inverse of this. So Laplace inverse of f dash of s, or rather minus f dash of s, is what? Laplace inverse of 1 by s plus a minus 1 by s minus a, which is e power minus at u of t minus e power at u of t. So which is nothing but e power minus at minus e power at u of t. But what is Laplace inverse of f dash of minus f dash of s? This is t into f of t. But I don't want t into f of t. I want f of t because this is my f of s. Laplace inverse of f of s is f of t. So they are asking me to find f of t. So I need to use the property. This is e power minus at minus e power at into u of t, which implies f of t is e power minus at minus e power at the whole divided by t into u of t. So this is the solution. So this is a very interesting, because this is not a conventional Laplace inverse. So if you see, all the conventional Laplace inverse will be of some polynomial or something like that, but this is totally unconventional. This is where this type of things comes into play. Clear? This is a very interesting application of the property. Okay, so this is very important. So the next question goes something like this. The question number 4 was impulse response of a system. So you have a system h of n is 1 by 2 power n u of n. So if x of n equal to, the question said what? Let's see. 2 delta of n plus delta of n minus 3. 2 delta of n plus delta of n minus 3, correct? plus delta of n minus 3, then what is y of 4? This was the question. So what is y of n? Y of n is nothing but h of n convolved with x of n. So h of n is given. H of n is 1 by 2 power n u of n convolved with 2 delta of n plus delta of n minus 3. So we know whenever we are convolving with delta of n, the answer will be same, correct? Because this itself is the impulse response. So whenever you are convolving with delta of n, but we are convolving with 2 delta of n, so the answer will be 2 times 1 by 2 power n u of n plus, and convolution of a sum is sum of a convolution. So convolution is associative and distributive, correct? So I can take it this way. Okay, there's a question. So, sir, what is the basic difference between Fourier and Laplace transform? Sanket is asking. Okay, Sanket, give me a minute. I will answer that. Laplace transform can also exist for unbounded signals, but on ROC condition. But in Fourier, it is not possible. That's a very correct statement, Sai Mahesh. That's very, very correct. That's exactly what we were trying to explore in the previous couple of problems. That's very much correct. Okay, so here the property we are using is Laplace convolution of a sum is sum of convolution. So suppose if I have a convolved with b plus c, I can write it as a convolved with b plus a convolved with c. This is the property I'm using here. So I will have the convolution of these two, then I'm going to write the convolution of this. So delta of n minus 3 is just a time shifting operation. So this will become 1 by 2 power n minus 3 u of n minus 3. So this is my y of n. So now y of 4 is what we need to find. So substitute n equal to 4. So I will get 2 into 1 by 2 power 4. U of n is going to be just 1. So so multiply by 1 plus 1 by 2. 4 minus 3 is 1. U of 4 minus 3. U of 1 is 1. So what is this? So this is going to be 2 in 2 by 16 plus 1 by 2, which is nothing but 1 by 8 plus 1 by 2, which is 1 by 8 plus 4 by 8, which is 5 by 8, which is 0.625. This is the correct answer. So Saket Samrat has asked, what is the difference between the Fourier transform and Laplace transform? Actually, that's a very interesting question. Let's answer that question. So if I take what is Fourier transform of x of t? Fourier transform of x of t is integral minus infinity to infinity x of t e power minus j omega t dt. So this is what is giving the representation of x of t in the frequency domain, correct? This exists if and only if integral minus infinity to infinity x of t dt is less than infinity. So my x of t is absolutely summable. So this is what they say, absolutely integrable. Okay, so Fourier transform exists only when you satisfy Dirichlet's condition and the x of t is absolutely integrable. Then the Fourier transform of x of t is given by this. Now suppose integral minus infinity to infinity x of t dt is equal to infinity. The x of t is diverging now. Now I can force a convergence on this by multiplying with a exponentially decaying signal who is decaying fastly than growth of x. See, x of t is growing to infinity means what? The integration is becoming infinity means that means x of t is growing all the way to infinity. Now I'm at what rate is going to infinity? Faster than that I'm multiplying a signal which is decaying. So the overall answer will be less than infinity, because e power minus sigma t will enforce the convergence, because e power minus sigma t is going to look like this. So now I need to pick such a value of e power minus sigma t which will ensure, say for example, my x of t is growing like this. X of t is e power 2t. Now if I multiply this with e power minus t, this is e power minus t, e power 2t into e power minus t, the answer is e power t. Now e power t will again look like this, which will grow to infinity. Whereas if I multiply e power 2t with e power minus 2.00001t, the answer will look like e power minus 0.001t. Now this will look like, now this signal is a converging signal. This will convert. So I should pick such a value of e power minus sigma t such that the result is converging. Now, since this result is converging, I can take Fourier transform of this result. So let us take Fourier transform of this result. So Fourier transform of the result will be what? Integral minus infinity to infinity x of t e power minus sigma t into e power minus j omega t dt, which is nothing but integral minus infinity to infinity x of t e power minus of sigma plus j omega t dt, which is what I call as minus infinity to infinity x of t e power minus st dt. This is what I call as my x of s Laplace transform. So I am enforcing the convergence by multiplying with e power minus sigma t. This is the biggest difference between Fourier transform and Laplace transform. So there will automatically be a notation of region of convergence because the answer will converge only in those regions where this condition of convergence is satisfied. So this is the difference between the Fourier and the Laplace transform. Okay. Clear? Clear? Saket Samrat, did I answer your question? Okay. Let us go to the next question. This is the last question we have. So we have a differential equation. Let us pick the different differential equation. Yeah, y double dash plus 3y dash plus 2, y double dash of t plus 3y dash of t plus 2y equal to x dash of t plus x of t. So what is step response? This is the question. So let me take Laplace transform on both sides. So because this is a differential equation which is describing the transfer function of the system, clearly I can assume the initial condition to be 0 because nothing is told in the problem. That is a fair enough assumption here. So s square plus 3s plus 2 times y of s will be s plus 1 times x of s. So therefore y of s is nothing but s plus 1. I'm going to factorize this. S square plus 3s plus 2 can be written as s plus 1 into s plus 2 into x of s. So s plus 1 gets cancelled. So I have x of s divided by s plus 2. So now they are asking you to find step response, correct? So y step of s. So what will be x of s? X of s will be, so x of t is u of t. So x of s will be 1 by s. So this will be 1 by s into s plus 2, which is nothing but a by s plus b by s plus 2, which can be simplified as 1 by 2 into 1 by s minus 1 by s plus 2. So if you simplify it by partial fraction, this is what you will get. So therefore y step of t will look like 1 by 2 into 1 by s Laplace transform is u of t Kindly, guys, many people write the inverse Laplace transform of 1 by s as 1. It's not 1. Laplace inverse of 1 by s is u of t. Kindly note. Laplace transform of 1 does not exist. Laplace transform of 1 will not exist. We need to be very careful. So Laplace inverse of 1 by s is u of t minus 1 by s plus 2 will be e power minus 2t u of t. So it is 1 by half u of t minus half e power minus 2t u of t. Clear? So this is what is the answer. This is the solution. Okay. So I hope this session was really informative, and we saw a lot of, we saw the all the interesting nuances and properties, and we also saw the difference between what is Laplace transform, what is Fourier transform, what are the, how to apply the properties of Laplace transform, how to find the transfer function, how to find the step response, how to find the impulse response, all those things. I hope this session was informative. Okay, wishing you all the best, guys. Thank you very much. I think we can close the session here. If there are any questions, I like to take it up. Otherwise, we can call it done. Okay, I think we can call it done. Thank you, guys. Thank you.